Welcome to Creative World. In this video, we will solve Learning Assessment E3.2. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning Assessment E3.2. Find all node voltages in given below figure using MATLAB. This is the circuit diagram of given problem. Inside this network, we have to find all these node voltages which are labeled as V1, V2 and V3 using MATLAB. So without wasting time, let's proceed towards the solution. First of all, we will simplify this network to find all node equations. If we succeed to find out all node equations of this particular network, we will place that equations inside MATLAB to get node voltage values. So we will apply node analysis technique on this network to find all node equations. And we know that in order to apply node analysis technique, first of all we have to find total number of nodes present in the network. In this network, total 4 number of nodes are present. One of them is reference or ground node. The remaining node will be utilized to calculate node voltages. So out of 4, the remaining nodes are 3. So 3 number of node equations will be found from this network using node analysis technique. Before we apply node analysis technique, first of all we have to assume all unknown branch currents along with their directions. I am assuming these branch currents with specified directions. On this node, current I1 and I2 is leaving while 4 mA current is entering. Similarly, on this node 2 that is labeled as V2, one current is entering I2 while 2 currents are leaving I3 and I4. And on this node, 2 currents are entering, one is I1 and other one is I4, while only one current is leaving, that is 2 mA. Now we will start finding out the node voltage one by one. First of all, we will apply Kirchoff's current law on this node. On this node, one current is entering, that is 4 mA, and it is taken with positive sign, while 2 currents are leaving, I1 and I2. Now we have to replace these two currents with their respective equations. Current I1 will be equal to voltage across this 1 kΩ resistance divided by the value of resistance. Because current is leaving from this node, it means this node will be on higher potential than this node. And voltage across this 1 kΩ resistance will be equal to the difference of these two node voltages. So we can say that current through this 1 kΩ resistance, that is I1, will be equal to difference of these two voltages divided by the value of resistance, V1 minus V3 divided by 1 kΩ. Similarly, current I2 will be voltage across this 2 kΩ resistance divided by the value of resistance. In this case, current is leaving from this node. It means this node is on higher potential than this node. Voltage across 2 kΩ resistance will be equal to the difference of these two node voltages, V1 minus V2. So we can say that current I2 will be equal to V1 minus V2 divided by 2 kΩ. Modify this equation by replacing these two currents with their equations. I1 is equal to V1 minus V3 divided by 1 kΩ. Similarly, I2 is equal to V1 minus V2 divided by 2 kΩ. Now, in order to omit all denominator values, we will multiply this equation with 2 kΩ. Product of 2 kΩ and 4 mA will result 8 ampere. Milli will cancel out with K. Here product of 2 kΩ and V1 minus V3 divided by 1 kΩ will result 2 into V1 minus V3. Similarly, here product of 2 kΩ will cancel out 2 kΩ in denominator. only V1 minus V2 will left. Now open these brackets. This minus 2 will multiply with V1. It will become minus 2V1. And this minus V3 will multiply with minus V2. It will become plus 2V3. This 8 ampere is placed on the other hand side of equal to separate constants from variables. Similarly, minus 1 is multiplied with V1, it will become minus V1. And this minus will multiply with minus outside of bracket, it will become plus V2. Now arrange this equation by adding this minus V1 and minus 2V1, it will become minus 3V1 plus V2 plus 2V3 is equal to minus 8 ampere, and this equation is labeled as equation A. This is the first node equation of this network. Now we will apply Kirchoff's current law on this node to find out second node equation. On this node, one current is entering, that is I2, and it is taken with positive sign, while two other currents that are leaving from this node will be taken with negative sign. In this equation, we have to replace these all currents with their respective equations. Current equation of I2 was previously calculated, that is V1 minus V2 divided by 2 kilo ohm. Similarly, current I3 will be calculated using this node voltage that is appearing across 1 kilo ohm resistance divided by the value of resistance. So I3 will be equal to V2 divided by 1 kilo ohm. Similarly, I4 will be equal to voltage across this 4 kilo ohm resistance, that is equal to the difference of these two voltages. Because current is leaving from this node, so this node would be on higher potential. So voltage across this 4 kilo ohm resistance will be equal to V2 minus V3, and current through this 4 kilo ohm resistance will be equal to V2 minus V3 divided by 4 kilo ohm. Modify this equation by replacing their respective current equations. I2 is equal to V1 minus V2 divided by 2 kilo ohm. I3 is equal to V2 divided by 1 kilo ohm, and I4 is equal to V2 minus V3 divided by 4 kilo ohm. Now in order to omit all denominator values, we have to multiply this equation on both sides with 4 kilo ohm. Product of 4 kilo ohm and V1 minus V2 divided by 2 kilo ohm will become 2 into V1 minus V2. Similarly, product of 4 kilo ohm and V2 divided by 1 kilo ohm will become 4V2. And at the end, product of 4 kilo ohm and V2 minus V3 divided by 4 kilo ohm will result V2 minus V3. Now open these brackets. Product of 2 and V1 minus V2 will become 2V1 minus 2V2 minus 4V2, and this minus will multiply variables inside the bracket. It will become minus V2 plus V3. Add minus 4V2 minus 2V2 and minus V2 together and arrange the equation. The equation will become 2V1 minus 7V2 plus V3 equal to 0, and this equation will be labeled as equation B, and it is the second node equation of this network. Move towards the last node of the network. On this node, two currents are entering, one is I1 and other one is I4, while only one current is leaving, that is 2 milliampere. Now we have to replace these two currents with their equations. Current I1 equation is V1 minus V3 divided by 1 kilo ohm, and current I4 equation is V2 minus V3 divided by 4 kilo ohm. In order to omit values in denominator, multiply with 4 kilo ohm on both sides. Product of 4 kilo ohm and V1 minus V3 divided by 1 kilo ohm will become 4 into V1 minus V3. Similarly, product of 4 kilo ohm and V2 minus V3 divided by 4 kilo ohm will become V2 minus V3. And product of 2 milliampere and 4 kilo ohm will become 8 ampere. Milli will cancel out with kilo. Open these brackets and place minus 8 ampere on the other hand side of equal to separate constant from variable. 4 will multiply with V1, it will become 4V1, and 4 will multiply with minus V3, it will become minus 4V3. And these will become V2 minus V3. Add minus V3 and minus 4V3, it will become minus 5V3, and arrange this equation. The equation will become 4V1 plus V2 minus 5V3 equal to 8 ampere, and this one is the third node equation of this network. As we have discussed earlier, this network will have 3 node equations which are found. So now we have to use MATLAB to find 3 node voltages. For that purpose, we are using matrix inversion method to calculate 3 node voltages. So first of all, we have to find matrix from these 3 node equations. First matrix will be coefficient matrix and it will be labeled as matrix A. This will include all coefficients along with these variables inside these 3 node equations. Second matrix will be labeled as X and it will include all variables which are required to calculate. These are V1, V2 and V3. And last matrix will be labeled as matrix B and it will include all constants -8 ampere, 0 and 8 ampere. Now we know that in matrix inversion method we place this coefficient matrix on the other hand side of equal by taking its inverse and multiply it with constant matrix B. Now we will move towards MATLAB. We'll define these matrix and find these 3 node voltages. Here is the MATLAB code which I have performed. First of all, we have defined this matrix A. Then matrix B is defined using this syntax. And then we have taken the inverse of matrix A and multiplied it with constant matrix B. So the values of node voltages are V1 is equal to 5.4286, V2 is equal to 2 volt and V3 is equal to 3.1429 volt. So this was learning assessment E3.2. Thank you. See you again in next video.